I'm going to give you some vocab right now. And so I've given you some vocab. We've talked about linear programming. We talked about constraints in feasible regions. And now we're going to talk about optimal solutions and an objective function. Pardon me? Yes, please take this down as notes. Okay, so optimal solution. An optimal solution is the best solution, but you need to know what your goal is. So remember the pizza problem that we did yesterday. Okay. What would you think their goal is in that pizza problem? Profit. Do they want to maximize profit or do they want to limit profit?
Maximize.
They want to maximize it. Okay? So that is what you need to always think about. How do I maximize it? And it depends on what the problem is. So that is what you're going to be looking for, is an optimal solution. And then we're going to be talking about, I'm just moving this up a little bit, the equation that gives the value of the quantity you want to optimize in terms of variables, and the problem is called the objective function. Now, yesterday, and again, we're talking about that pizza problem that we did. We had two kinds of pizzas, right? The 12-inch and I think the 16-inch. Okay? How much was that pizza problem? I mean, how much, do you remember how much the pizza was?
$4 and $2.
Okay, let me see. That's right, $4 and $2. Okay, so the objective function in this case, okay, is we are looking to maximize our profit. And our profit statement is going to be an equal sign. And I don't remember what variables did we use. Did we use X and Y?
I think so.
Okay, so it was $2 for the little pizza and $4 for the large pizza would be our objective function. Okay, and it's written as an equal sign. And in this case, it was profit. P equals 2x plus 4y. Okay, and when I finish this, we'll look at that problem in a second.
Wait, what is that word saying at the bottom of that?
I'm sorry, I didn't hear you.
Profit, Eli.
Profit
No,
equals
not that. They meant like is called. Oh, is called.
Does that say that gives?
is called the objective function. Okay, because sometimes the directions will ask you for the objective function, and you need to know what that vocabulary means. And so we'll go back and we'll look at some problems with objective functions in it. Okay? All right. So when we were doing the pizza problem, did I cover this? Is everybody done with this?
I'm almost done.
You're almost?
Yeah.
Who else needs this?
Everyone just scribble it.
Okay, so if you look at your pizza problem, we were looking at the vertices, and we know that the shaded region gives us the feasible region, but we're looking for the optimal solution. And how did we find the optimal solution on that pizza problem? Okay, we graphed it, but there were certain places that we decided to check. And at one point we thought, let's look here, and when we plugged in, when x was, let me see, what did we do? When x was 1200, and y was 0, we ended up with, was that 2400? And let me see, is that right? Okay. When we looked at the other one, when x was, or how about here? I think we had when we looked over here and we found this vertex. We found, I think this was 200 and 800, I believe that was. I think that was 200 and 800. And we plugged those in. We had 2 times 200 plus 4 times 800. We ended up with 400 plus 3,200, and that was what? 3,600. So we can find our the optimal solution by using our vertices and plugging it in, and that's what we're going to do now.
Wait, so is that always one of the vertices?
That's a good question. Okay. When we tried it here, we tried one of these, and do you think it would be a region in the inside? I mean, we could try that, and we could see what combination. So on this graph, let's see, when x is, let's go with x is 900, and then we could graph a point in here, which is what, 1100? 150. So when x, this is 900, and I think I had, what did I just say?
It's 900, 150.
150. Let's see what happens. So, 2 times 900 is what? 1,800 plus 4 times 150 is what? 3,600, and it's 2,400.
Where'd you get 2 and 4?
It's $2 for the small pizzas and $4 for the large pizzas. Okay, that was the
We don't
part.
have that.
We didn't need that for the previous problem, but we need it now for our profit statement.
Oh, gotcha.
Okay? All right. So let's look at, okay, turn. Oh, I can show you this.
Wow,
Yes.
don't forget to hand back the test.
Thank you. I'll do that right now in a second. All right. So the problem sometimes arises, and this is the problem that we had talked about yesterday. We talked about the coffee bean problem. Do you remember that yesterday? Okay, we talked about this coffee bean problem yesterday, and look how many. So how do you know which vertex to choose? How do you know? In this particular case, remember they were selling 2 kinds of coffee, and we're looking for, well, what is the best combination for her? So we need to identify the 3 vertex points, and I believe we have them here as 0, 0, and then T is what, 0, 300, U is, I'm sorry, 2,000 and 3,000, and V is 3,500 and 1,500, and W is 4,001. How do I figure out which one is the best one for us?
Plug it in to your
You have to
objective
plug it in.
function.
You have to plug them in. And in this case, I'm going to just show you this so I can speed this up for you. If I plug in all those points, is one of them your optimal solution?
Yes.
Okay,
V.
and so for them, for the profit, it is at what? V? And let's look at what V is. Okay, so you can't always just say, oh, it's going to be here or it's going to be there. It's a trial and error, and you have to plug in all the vertices and the coordinate points. Does that make sense, everybody? Okay. So, hold on a second. Let me just tell you what I'm going to ask you to do.